All right, so that was a very brief introduction to the reference architecture. It's still being discussed, but the basic principles are as has been described there. And now we move on to the security and privacy subgroup. This is not an area where I'm as expert as in some of the others, so I will not do it as much justice, but it is a very thoughtful, systematic approach, which I found a pretty good way of understanding all the difficult things we have to do to make this work secure. So it has exactly the same generic requirements, and then its tasks are at the gate to basically look all over the various stakeholders, the users and the providers and the developers, and get all the different security and privacy concerns from in all aspects of big data. Try to analyze them in terms of special challenges, classify their special challenges, look at the round 10. These are special use cases coming from this group, which are different from the broader use cases which are gathered by the requirements and use case subgroup. And then we want to develop a security and privilege architecture to describe how these various concerns can be or should be implemented and overlaid onto the reference architecture for the whole big data processing. So previously, a big data working group from the Cloud Security Alliance, they identified the top 10 big data challenges. And these, we will see these on the next slide. And the nice thing about both these slides is they really not only write down 10 challenges, they tell you where they are in the architecture. So we have here a whole bunch of devices, and here we have the different, here's challenge 4, end-to-end input validation and filtering. So 4 occurs here and here. The compute cluster has a whole bunch of these challenges. 10 is data provenance. That's keeping track of everything that's going on. Here we have a SQL database or just data storage. It's all in our public, private, or hybrid public-private cloud. And so these are the different components of the big data processing, the data streaming in, the system being tracked, data being stored, data running on clouds, and clusters being accessed. I will go through these actual, what these 10 are on the next slide. Right, so here are these 10 challenges, and they're classified into 4 areas: infrastructure security, and that involves trying to do computations that are secure in distributed programming frameworks, and also for best practice outside relational databases, because HDFS and NoSQL has its own special challenges not addressed necessarily by the database community. Privacy is particularly important. It involves keeping commercial secrets properly firewalled to the companies that owns those commercial secrets. It requires for health applications, keeping things private. And so you need to be able to understand how to do data mining and analytics to do preserving privacy. It's well known that if you not careful, you can produce results which can be reverse engineered to find out actually who was involved, which people were in the data analysis, because some people have very distinctive correlations, in particularly unusual diseases or particular critical technology, proprietary technologies which allow them to be identified. So there are things, ways of trying to do data-centric security to keep the data secure using cryptography. The question is what the performance implications are. And we need to have access control, which has enough granularity that you allow people who should have access, and we are able to provide a role-based or similar authorization that stops people who shouldn't be able to do something from doing it. We have to actually manage the data um, with proper logs which are secure and audit it. And then we already mentioned on the previous slide the importance of provenance. Part of the security is knowing what you did to the data. It's not just stopping from other people from looking at it. You better be able to look at it yourself and know what happened. And we need to do the validation at the beginning and at the end and monitor the security in real time. So those are those 10 challenges which are classified into these 4 areas. So this subgroup, which I was not involved in, so it's not really my field of expertise, but at least I understand these use cases. We have retail, e-commerce, and then we have things like Nielsen home scan that must have some security issues, privacy issues as to web traffic analysis. How much of the data can be exposed, or how much should the analyze and the analytics be prevented from looking at. Healthcare has a lot of important privacy issues, and also some issues about trial data, what can be shared and what can't be, and to what extent you can actually exchange data, or whether it needs to be kept proprietary to each healthcare provider. Cybersecurity is a generic term to describe the security of network systems, and is of growing importance. Another use case is the government, with military especially is critical. And I must admit I'm not quite certain what the education use case is, except obviously universities are very nervous about keeping, because they essentially have a lot of students they're responsible for. They need to be very careful that the information is properly disseminated and only given to people who need it, and is not given to people who don't need it. And there are three military use cases in the 51 we present later, and all of those have critical security, starting at the sensor gathering the data, maybe in the warfront, back to the through the network transmission, the processing, and the final access to the processed data. So here is superimposed on the basic reference architecture these various categories of challenges are listed, and also with some more detail. Endpoint input validation obviously starts here with the data provider. This has to be screened in real time as it's streamed into the analytics, and we may need to aggregate data. That has to be done in a secure fashion. When we consume it, we have to worry about freedom of information issues, compliance with regulations like HIPAA, and using analytics that do not give away information that should not be given in an incidental fashion. And here we have all the security issues connected with the actual processing of the data, and here we have issues connected to storing the data. And while it's running, we have to worry about denial of service, DOS attacks. And all of this has to have provenance attached to it. So that's how the reference architecture is mapped into some of the key security areas.